Hello and welcome. My name is Shannon Kemp and I'm the Chief Digital Manager for Dataversity. We'd like to thank you for joining today's Dataversity webinar, Data Architecture and Data Modeling Differences, Achieving a Common Understanding. It is the latest installment in a monthly series called Data Ed Online with Dr. Peter Aiken. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. For questions, we'll be collecting them via the Q&A in the bottom right-hand corner of your screen, or if you like to tweet, we encourage you to share highlights or questions via Twitter using hashtag DataEd. To open the Q&A, just click the Q&A icon in the bottom middle of your screen for that feature. And if you'd like to chat with us or with each other, we certainly encourage you to do so. Just click the chat icon also for that feature. To answer the most commonly asked questions, as always, we will send a follow-up email to all registrants within 2 business days, containing links to the slides. And yes, we are recording and will likewise send a link to the recording of the session, as well as any additional information requested throughout the webinar. Now, let me introduce to you our speaker for today, Dr. Peter Aiken. Peter is an internationally recognized data management thought leader. Many of you already know him or have seen him at conferences worldwide. He has more than 30 years of experience and has received many awards for his outstanding contributions to the profession. He has written dozens of articles and 11 books. The most recent is Your Data Strategy. And Peter is experienced with more than 500 data management practices in 20 countries and consistently named as a top data management expert. Some of the most important and largest organizations in the world have sought out his expertise. Peter has spent multi-year immersions with groups as diverse as the U.S. Department of Defense, Deutsche Bank, Nokia, Wells Fargo, the Commonwealth of Virginia, and Walmart. And with that, let me turn everything over to Peter to get today's webinar started. Hello and welcome.
Welcome to everybody. Thank you so much, Shannon. It's always such a pleasure to work with you on these things. Quick reminder of everybody, there's special event pricing on a couple of these books that we're going to talk about today, but that's not why you're here. You're here to understand the differences, or at least get an understanding of the differences between architecture and modeling. And the bottom line up front here is that it's data mapping from 2 different perspectives, but purposely aimed at achieving a common understanding. Let's dive into things and talk about a couple of icons that I'll be using throughout. This one, which is really hard to figure out, just think of it as a blob right now, is a conceptualization of a data architecture for some organization somewhere. The details do not matter. It just represents data architectures for a shorthand. This here is a component of a data model, so it'll be the high level. And the key between the two, of course, is that the data model on the right is much more detailed for precisely a good set of reasons than is the architecture, but the architecture is much more comprehensive. You can't be both simultaneously, and most organizations are built more like Swiss cheese in their architectures, in that there are big holes and areas that they don't understand, and most of the time, quite frankly, don't need to understand as a direct impact of the business is working on. We'll dive into all of these. So let me back up for a minute and talk about what we're going to talk about here for a minute. So the first question is, why do we need models? And the answer is because data is complex, and data models are used to answer specific questions. They're also used for documentation, but there are challenges to getting us to increased use. And I'll talk about 3 categories of social, political, and economic challenges to getting increased use out of data models. I'll then talk about architecture and engineering as not the opposite of, but data maps are detailed architecture, as I mentioned before, is a high level perspective, but they are looking at the same data. And so they're two sides of the same coin, if you will. They have to operate on standard shared data of known quality. That's important, not of necessarily high quality, but at least of known quality. And that's a challenge. The reason you guys are asking this question is because we teach students perhaps in a less efficient manner than we could. They typically learn something what we call forward engineering, with the goal of building something new. And that's easy to conceptualize, certainly as a reality. But in many cases, or in fact, the vast majority of cases, the students upon graduation will do with data what we all need to do more of, which is to reverse engineer it to understand what's actually there. Because working together with that reverse engineering, it allows us to do what many people call re-engineering, although they they affect that process incorrectly. And so we'll finish up here in about an hour to talk about the need for simplicity to go at these things and to make sure that these two processes, modeling and architecture, are working in concert in your organization. Of course, we'll get to a couple of quick takeaways and look for the Q&A section at the end here, which is always the most fun for Shannon and I as we've been doing this. So here we go. Data just as a subject is complex and detailed and really inconsistently taught, and as a result, poorly understood. But these data maps are models that are necessary but insufficient prerequisites to data architectures. In other words, if you don't have the data maps, you will not have the data architecture by definition on this. These models tell us what's going on. They help us leverage data assets. So we have some data that is of high curation value. It has been nicely prepared and can be used to great effect. That's the goal of leveraging in there. However, if we don't understand the data, we have no ability to leverage it at all. And most corporate data, organizational data for that matter, is underutilized, is underanalyzed, is not analyzed, in fact. And we'll talk specifically about how these maps are really incomplete in that they're taught to be defined as opposed to purposed. And a purpose statement is a more powerful definition, of a more powerful reason. It provides motivation along with the idea of the things that we're looking at. Why are we looking at data in this fashion? Well, if we have a purpose statement, it guides our analysis and shows that we're trying to get to a specific answer. As I said, they're more powerful than the definitions on this. The remedy is, of course, to add these things. We'll come back to that in just a bit. The maps are absolutely required to share information about these data architectures because the architectures are composed of the models, and the modeling is an engineering activity, but it doesn't give us the ability to leverage the maps. Let's jump into this a little ways. If you aren't familiar with this, most of the world wasn't either until 2009 when DAMA International introduced the data management body of knowledge. Its popularity helped us to codify the areas around what it means to do data modeling, which is not a subject that many people have been introduced to. We're going to be talking today around, first of all, the modeling component, which we call a practice area in here. And it focuses on analysis, database design, implementation, additional types of data development. But as you'll see very quickly, it's mainly backwards looking that we're doing in today's environment than it is forward looking, or we should do more forward looking, but we're not doing the right kind of forward looking, and we're not doing practically any backward looking. One of the reasons that data is difficult for people to conceptualize is that it doesn't obey the laws of physics, as Doug Laney so handsomely put it in his wonderful book, Infonomics, where he addresses some of these topics here. It's not really visible. That's why visualization is such a valuable skill in this field, but data is what we call non-rivalous, and that just means that the cost of providing an additional copy of a set of data is zero, making it, of course, highly easy to steal too. It does not deplete. It doesn't require refreshment. I've literally had the same email address, I think, since 1981, I believe. And it's on every spammer's list out there, but it does not require replenishment. It is still accurate from that perspective. Its ability is to be regenerative. It can be unlimited is not a great word, but it's conceptually closer to what's out there than actually looking at any specific limits. And that's an interesting discussion in and of itself. They're very low inventory transmission costs. It's more difficult to control and own. It's very eco-friendly as long as you're not doing too many clicks or likes in the social world. Again, different topic we'll get into. And Doug's final point here is wonderful. It's impossible to clean up if you spill it. And that does make it challenging. Now we're going to come back and forth from the slide a couple of times. So this is to show you what we're going to cover during the data modeling piece of this session here. And that is the idea of going through and getting the process of discovering, understanding what these things do and how they interact. We'll talk about this piece and we'll dive into this one and this one. You'll see how we work our way through this. So the first one here is, again, the process of discovering, analyzing, and scoping data requirements. And one of the important things for organizations to have if they are to manage data as an asset is just simply the lists of the persons, places, or things that are important to that organization. And more importantly, a formal process for creating, reading, updating, deleting, and perhaps archiving information that it pertains to these entities. The specific details are called attributes. And attributes make up characteristics of things. For example, an attribute of Peter is that I am located in the Commonwealth of Virginia in the United States of America. That's an attribute that belongs to me, belongs to many of the rest of you as well. But anyway, it's one of the ways in which we characterize things. So here's a model we're going to work with for a slide or two. As thinking about what I had on the previous slide, an organization might say, I need to understand these things about a thing. So I want these parts, and the parts are clearly ID, description, status, sex to be assigned, reason, reserve. All right, now notice we've already got a incompatibility problem here in that these are the attributes, but they aren't exactly the attributes that we have down here. So we don't know for a fact that there's a one-to-one correspondence between these things, but at least for this exercise, please assume that particular piece. Thing ID is the way of identifying one specific thing out of this class of things, which is what this entity structure here represents. Decisions to manage a specific attribute have consequences, and this is why we say data is detailed. In this particular case, a decision to use this data attribute about sex to be assigned means we will understand female things are to be reserved in this case, as opposed to male things that are there. We don't know what the things are, but it's important to this organization. It's material. It's essential, to quote David Hay on that particular script. By the way, David, I hope your origami is going well down there in Houston. Characteristics that people are sharing in here. Things could have a status according to this particular data model that is postulated, and many things can be assigned to females. And ID gives us one thing that's different from every other one. The description is likely to be unique for each thing in there. And one of the ways to test as to whether this is working well in your session or your thinking is that when you propose a new entity, think of and write down 3 specific instances of that entity. It will just help your thinking now and later to understand a little more about that. So that's the first part, why you use this to discover, analyze, and scope the data requirements. Those data requirements are specified as a model that I just showed you, a component of a model. The next piece of this then is representing and communicating these in a precise form called a data model. So here's a data model that's more complex. It takes thing 1 that we had in the previous example and connects it to thing 2 with a relationship that really doesn't occur very often naturally in the world. That relationship is represented by the code shown in the orange there. Each thing 2 must be accompanied by a thing 1, and each thing 1 must be accompanied by a thing 2. The reason that's sort of unnatural is because if you've got that much correspondence between the two, there's likely to be perhaps a bigger thing, perhaps a thing 1 plus 2 that would combine both of these things and perhaps be more efficient, but you won't know until you've done analysis along that. But nevertheless, we're representing that thing here. By the way, this notation stuff that I'm showing is very easy to learn. That looks like a 1. Well, it is. We'll see a couple of other notes that do something similar. And unfortunately, there have been, up until recently, competing examples of this. So you'll see this in the literature perhaps, but moving ahead, I'll be using the language that everybody else has adopted, which is information engineering. These relationships here define mandatory and optional, as well as maximum and minimum occurrences. And the beauty of what was invented here is that it can account for every case. There are some limitations to the structure in general, but it's a very nice way, a precise way, an accurate way, a well-managed way of moving your attributes from thought into build, or perhaps from build into rebuild, which is where most of us are at in this particular scenario here. So we go back here to the representing of precise things. Again, the maps of critical business assets. We're composing metadata is what we're doing. These maps function as sheet music over here. And that sheet music is the thing that guides not just us, but others that come after us. And yes, these systems do last that long. I remember working on systems that were 40 years old when I was back in the 70s. So it's kind of crazy from that perspective. There's a lot of it out there, though, and that skill and understanding it is very much marketable. Metadata gives you the link between the technical and what you're doing with it from a business perspective, these definitions and the lineage if you're doing analytics. And the last part of this data modeling piece right here is the idea that data modeling is iterative. So these both architectures and models are created in response to organizational needs. We use the word instantiated because we want to get paid a quarter for it, but it means built in or integrated into a data model. So this data model is expressing some kind of organizational need. Now, sometimes that organizational need is known in the business and it's called a business rule. Sometimes it's not known in the business, but it's in the IT system, and that's when you need to reverse engineer to find out factually what is actually happening in your systems. And again, part of the $1.5 billion that I've saved organizations has been due to that precise understanding of these. The data model then authorizes and articulates an information system requirement. And if we are really good at this, we will put a feedback in to make sure that we satisfy the specific organizational need. The challenge is most organizations pick up this as a one-off practice, whereas they really need to understand it's a continuous process that does not stop. And the reason it doesn't stop is because if your organizational needs stop, then this process would stop. But we know that organizational needs evolve over time, therefore your data needs will evolve over time. Again, this is the sum of the data modeling process. It's discovering, analyzing, and understanding the specifics of your data requirements, communicating them in a precise form, and then understanding that you don't do it once, but it's going to include an iterative process. Now, there's another part of this as well, which is that there's a subdivision here of data model types. And it's just important to be aware of them. The first one is a conceptual model where everybody gets a view of this particular piece. And David would love me to say motivation should be a component of this. And I hope I got that right, David, but I think that's what he was angling for on that. The logical components here then start to get into the physical aspects, which means you may now specify a specific data store as opposed to a generic data store on the top. And then physical, where you'd say, well, we're actually going to put it in the cloud. Well, that's fine. This is where it would be specified. And the reason to do that is because you want your physical store to be completely transparent to the user community. And one of the biggest examples of this was that Facebook at one point in its career was operating on Microsoft SQL, which is a great platform, but Facebook, of course, is a behemoth. And consequently, they had to transform off of that platform into literally a technology that they invented themselves to satisfy their own needs, doing this precise process that we're describing here. And that would have been a death blow to Facebook. Not many people are aware of it, but it's a really interesting story if you want to get out and take a look at some of the details on the web. So again, this iterative conceptual process here. So let's take a look at a specific example of a data structure here. And if you look it up, this is a NIST, that's a National Institute of Standards definition of it, or an organization of information, usually in memory, for better algorithmic efficiency. In other words, instead of just throwing it together in any old way, that there are ways of optimizing this. And depending on what your goals are, these optimizations can be helpful. Again, they list a bunch of them here, but more importantly, the data structure also defines a grammar in this case for the data objects. For example, you're looking clearly here at a way an organization calculates sales. There are other ways of doing this, and not knowing this can result in different parts of the organization not understanding the use of these particular, we call them grammars, the principles that they are using in this domain specific environment. That is a reason that you are going after a specific data question that you have or trying to solve a data problem that you've run into. They present constraints for data objects. These are things that you can do. If it's not on this diagram, it does not occur. This is the hardest thing for the younger generation coming along to realize, because you can get anything literally at your fingertips, but the data, if it's not arranged correctly, will be wrong for the life of the product, because once the database is created, it is very unlikely to be evolved from there because it's too difficult to process, considering all the programming that has been wrapped around it. We can talk about things like putting objects in sequential order, making certain characteristics unique, arranged alphabetically. How many of you have looked at the first 1,000 records of a data set and discovered that all your customer last names began with the letter A, right? Well, again, there's different relationships that we can talk about, and wonderful new big data, if you wish, technologies that have come into play here that are very complementary in nature to the things that we do. That was the problem. Everybody wanted to replace what we were doing. Complementing it is really the answer in there, and trying to balance this old with new, because that's the way it evolves. It's not a replace process, but optimization is absolutely possible out of this process. And again, what you see here is the way one company might define concepts of customer, sales order, product, and sales order line. Which, if you can't get that piece, bear with me for a couple slides, and we'll talk about the detail between two many-to-many relationships that are in there. For the moment, let's concentrate on the structure hierarchy, which is something that most people can relate to. Above or at the same level are the two options. And if you've got a mess, one of the ways of organizing that mess is to start to say, hey, how can we put it out in different ways? The way is the way in which models are organized to become a data architecture. Your data architecture is made up of these models. It's a way of making unmessy data less messy. There's a wonderful book. I don't think I do reference Abby Covert later on in this, but How to Mess with Any Mess. Wonderful book. I'll point it out when we get to it. Anyway, the idea here is that you've got a mess. If you organize it into hierarchies, like these things are on the same level or these are on a lower level, and we could have a multi-layered hierarchy. I just didn't show it on this particular piece. The accumulation, the Venn diagram, the union of all these data models and data model views are what make up your data architecture in here. But there are barriers to this being increasingly used. It's not expensive to use. The people who do this love to do the work and would love to help your organizations. I don't want to sound like I'm pitching you, but there's simply not enough done in the world in terms of this type of analysis here. And the skills are very needed. They just don't know what to call it. Let's get to the challenges here. Socially, it's a big challenge because what happens is that we've been running in IT, and IT, as good as it is, has been running data as a project, and data is not a project. So the way to fix this is to help educate everybody that your needs are programmatic. Now, a programmatic need that you can make seem very like data management needs is the HR program in your organization. Do as much as you can vocally and politely, persistently, to speak to people in the organization and say, data is increasing at an increasing rate, and we're not managing it. It is ungoverned at the moment. We are running data without governance. That's bad. People decided 80 years ago that running HR without governance was similarly bad, and HR is not. Nobody looks around to it and says, hey, I think we've done enough HR. I think we don't need lawyers. I think we don't need HR specialists. I think we don't need an HR program anymore. No, you need your data program to last as long as your HR program. Good luck. Happy to help you guys with that, but it's a tough sell in some cases. By the way, remember, you all are the motivated group that are listening out there. The rest of the world hasn't even figured out this stuff's important yet. So you've got the opportunity for a sustained competitive advantage. And one of the ways you'll achieve that better is to look at knowledge workers in your organization. 100% of them work with data, but of course, none of them have good education around that. Data education aimed at knowledge workers is going to be an important component in persuading your organization to better use the data maps. Business people love data maps, particularly when it gives them factual information. They understand how to use it. There are political dimensions to this nasty little fight too, and one of them is, as a university professor, I tell you that we are doing a very bad job in many cases of teaching students about data. The typical IT program still has exactly one course in how to build a new database. That's what they learn about data at the undergraduate level, unless they happen to wander into an elective or a good program, very much the exception rather than the rule. If there's a skill we do not need any more of on planet Earth, it is how to build new databases. The problem is more insidious than that, though. Not just haven't we taught people correctly in the last 30 years, but the impression that other people who either come in contact with or go through the program is that data is a technical skill that's only needed occasionally when I'm developing a new database. They don't teach them that the purpose of data modeling is understanding, and that's more important for diagnosis than it is building new things in this area. Another problem is that they don't see things from a data perspective. So they may actually be, I've had conversations, I'm installing a CRM, a customer relationship management. I don't need to know anything about new databases because it comes with one. Well, yes, that's a true statement, but what it doesn't come with is directions on whether their data structures will match your existing organizational data structures. And that's just one of the potential problems that you can have, that there's a hole in the organizational knowledge now. And we've taught them this way for 30 years. Consequently, they learn, as Maslow said very well, if the only tool you know is a hammer. Hang on, I screwed that up totally. The only tool you know is a hammer, the only problem will look like a nail. There you go, give Maslow his credit. Build a new database is the answer. We've taught them to every problem that they're faced with because we haven't taught them anything else. So of course it's going to be the answer. And it means we have a big, big social challenge, political challenge, and now economic challenge that we'll get around as well. Again, back to the political, though, you're still in this thing I call the bad data decisions spiral. And that is the idea that we've now taken literally 30 years of decision makers in the business side and the technology side and not equipped them to make data decisions well. They are data unknowledgeable. Those bad data decisions result in poor treatment of organizational data assets and poor treatment of data, therefore poor organizational outcomes that do not get recognized as data problems. This is the spiral we would like to break out of. We'll work with you on how to do that as well. Economic challenges around the use of data models, increased use of data models, and that's what I call its insidiousness. Now, I love to bring this particular example up. Galloping Gertie was a wonderful engineering disaster. I don't mean that it was a disaster. It was a plight that nobody got really hurt in it, but it was crazy. Let's just talk about it if you're not familiar. The world's third longest suspension build. Again, elegant. People looked at this and went, wow, that was beautiful. It opened on July 1st of 1940 and then collapsed on 7 November of the same year, probably not at the length of its intended lifetime, documented beautifully by the insurance company that was insuring it. So they wanted to make sure they got correct what went wrong on here. And they did learn some lessons from this. It's a wonderful lesson on they did a mess on this, and luckily it didn't hurt anybody, but it did destroy the bridge. Again, if you're not familiar with the footage here, you're looking at, I mentioned before that Safeco, the company that insured this, put cameras on the bridge and said, if it's going to blow up, we need to know what we did wrong. So wonderful use of how to figure out whether this stuff works for you or not. It goes, again, just imagine twisting the top of a can of Coke too many times. It's going to become not sustainable at some point and break up into pieces, which is, of course, exactly what happens here. The reason I'm showing this to you, though, is that data disasters rarely look like that. Instead, data is an incoherence, which manifests itself in many different ways, but not typically recognized as data. So bad treated data costs organizations money. First of all, were your systems explicitly designed to be integrated or otherwise work together? Because the chances of them happening to work together is little or none. And our 30 years of experience in this area has shown us that organizations spend 20 to 40% of their IT budget migrating, converting, and improving their data. That's some big savings to go after, and I'm surprised more organizations don't take advantage of that. A little bit documented in a book there, again mentioned in some sale, blah, blah, blah. Okay, so doing a poor job with data takes longer. Doing a poor job with data modeling costs more. Not doing data modeling at all is more expensive typically than doing data modeling. Delivers less if you do not do data modeling because you do not consider the thing in context, presents greater risk to the organization. Again, data is an important piece. This, thanks, by the way, goes to Tom DeMarco, who originally brought this to my attention here, and it's just wonderful to be guided by people like him over a career that I've been fortunate to have as well. Let's get to engineering. Let's start with Steve Jobs.
For some reason, Peter, we're not hearing that.
Thank you. Should have tested it first. Sorry, guys. Give a sec.
No worries. There should be a share audio.
Let's find the Zoom thing again. Remember, I hit it. There we go. Oh, I did share sound. That's really interesting. All right, let me try it again. Just a test, Shannon.
You like everything so
far? There we go.
Good.
Thank you very much.
You like everything so far? Good. Well, I'll try not to blow it. So I get to talk about iCloud. We've been working on this for some time now, and we're really excited about it. About 10 years ago, we had one of our most important insights, and that was that the PC was going to become the digital hub for your digital life. What did that mean? Well, it meant that that's where you were going to put your digital photos. Where else were you going to put them? Your digital video off your digital camcorder. And of course, your music, right? You were going to acquire it in the device or potentially on your Mac, and you were going to basically sync it to the Mac, and everything was going to work fine. And it did for the better part of 10 years. But it's broken down in the last few years. Why? Well, because the devices have changed. They now all have music. They now all have photos. They now all have video. And so if I acquire a song, I buy it right on my iPhone, I want to get that to my other devices. Right? I pick up my iPad and it doesn't have that song on it. So I have to sync my iPhone to my Mac. Then I have to sync my other devices to the Mac to get that song. But then they've deposited some photos on the Mac, so I have to sync the iPhone again with the Mac to get those photos. And keeping these devices in sync is driving us crazy. So we've got a great solution for this problem. And we think this solution is our next big insight, which is we're going to demote the PC and the Mac to just be a device, just like an iPhone, an iPad, or an iPod Touch. And we're going to move the digital hub, the center of your digital life, into the cloud. Because all these new devices have communications built into them. They can all talk to the cloud whenever they want. And so now, if I get something on my iPhone, it's sent up to the cloud immediately. Let's say I take some pictures with it. Those pictures are in the cloud, and they are now pushed down to my devices completely automatically. And now everything's in sync with me not even having to think about it. I don't even have to take the devices out of my pocket. I don't have to be near my Mac or PC. Now, some people think the cloud is just a hard disk in the sky, right? And you take a bunch of stuff and you put it in your Dropbox or your iDisk or whatever, and it transfers it up to the cloud and stores it, and then you drag whatever you want back out on your other devices. We think it's way more than that, and we call it iCloud. Now, iCloud stores your content in the cloud and wirelessly pushes it to all your devices. So it automatically uploads it, stores it, and automatically pushes it to all your other devices. But also, it's completely integrated with your apps. And so everything happens automatically, and there's nothing new to learn. It just all works. It just works.
I got to stop here for a second and just say that my dad used to watch these, and he understood and followed the architecture lesson here that Steve Jobs just gave, which was we're going to take the center of the universe from being the PC and replace it with the cloud. But he also added an important differentiator with his services versus what he saw as the competition's time. And you don't have to learn anything new. My dad literally called me after this event and said, I want that. And I hadn't watched it, and I had no idea what he was talking about. It was kind of a fun conversation for us at the time. So back on track here, architecture is about things, components. Whatever those components are, that's the gift, the beauty, the job you as architects need to do is to say, what are these things, what are these components, and what do those things do? And individually, you need to say this thing does this and this thing does that. Because if you have too many things doing this and doing this and doing this, that's redundancy, and that may or may not be in the mission of your organization. Again, architecture supports mission around that. And then the question is, how do those things interact? Silliness, I know. Organizations typically manage different types of architectures, but when I say that, my experience over 30 years here has been that 1 in 10 organizations tries this, and 1 in 10 of those organizations does it well. If you're doing it well, reach out. I'd love to hear more about it and find out what makes you successful, because that's what our role here is to make everybody more successful around that. Types of architectures managed, again, business, process, system, security, the list goes on. The problem is if management believes technical committees are there and you're not just meeting and not doing anything, that's a problem. So you need to demonstrate value out of these activities, and that's tough. That's why the numbers are so low in that context. Let's take those same types of architectures here and give you one additional fact about it, which is that I get calls all the time where organizations say, please come help me create a data architecture. The only time you create a new data architecture is when nothing exists. If something exists, you need to treat it differently. All organizations that exist have a data architecture. The question is it understood? And by that, it means documented, because it cannot be useful if it is not understood and it is not documented. The focus of a data model is going to be a domain in general, an area, something you're trying to find out. For example, a software engineering effort may be looking at a program. An underutilized data modeling effort may say, hey, I'm going to look at the data aspects of program B, but a better use for it is to take it at the database level, which is typically what happens at program A, B, and C, all access database Brown, whatever that is. And we now come across as an integrated set in that they're all sharing knowledge of the same data structures. That's why it's so difficult, because for every data structure I have to change, I have to examine potentially every program for not just cosmetic changes, but also structural changes to the program, which can have an impact on performance, and system performance can affect customer experience. It gets real very quickly. So the rule is generally don't mess with them, but they haven't been built well in the first place. Enterprise resource packages and commercial off-the-shelf software are marketed as being similarly integrated. And the answer is likely to be yes, they are integrated that way. It doesn't mean that the original data model is any good. I made my living for many years just taking the existing data models of packages that are out there, the big names, and changing it, taking it and exposing it so that everybody could understand what had been done to their specific version of it, or what was happening in the actual package. Again, from a database perspective, you may have somebody taking care of the brown and somebody taking care of the green. It may be the same or a different person taking care of the orange here, but that is typically the way it would evolve. When we look at it from a data architecture perspective, we have a greater value potential. And that's because we're looking on broad use across all of the databases on system perspectives as opposed to individual system perspectives, on organization-wide concepts. So again, not program A system level, but when we look at the combination of brown, orange, and green, that's the system that we're talking about there. But you can see even that distinction is unclear without the model here, and that's one of the things we need to have. This takes us now to another component, which is architecture. And architecture is, whoops, I'm sorry, I'm going to go back. Went by too fast there. Data architecture is about understanding data modeling at the enterprise level. Now, again, the same numbers apply 1 in 10 and 1 in 10 in terms of doing it and doing it well. That said, a lot of organizations are learning from it and using it. Doesn't mean that nobody's doing it. It just means there aren't many out of the total population that are doing it. And those of you that are doing it are being great about sharing your perspectives in that area and letting everybody else see how it's going. This also adds the idea of value chain analysis. How do you justify an architecture? How does an architecture support the overall mission of the organization, public sector or private sector in there? And is related to the concept of data architectures in there as well. So again, let's dive into it here. How are components expressed as architectures? Details are organized into larger components, a pattern you will see repeated throughout the world. It makes sense to do it here as well. And that adds intricacy to the data components because those details are done for a reason. I just showed you that determining whether a resource, a thing, was to be assigned for a sex reason was important enough to build in. If it wasn't built in, it cannot be done except with great trouble later on. You'll see that quote in just a second. These larger details are organized together into models, and that adds a series of dependencies. If I have a want to get from A to D, I need to understand the relationship between B to C. Is just one of many, many interpretations you can take from this. But again, the pattern, larger components are organized into models here. And finally, we take those models and organize them into architectures. And that adds purposefulness, because you don't just do something, you do something for a reason. And that reason is important to us. Let's look at the same thing from the data perspective now. I'll keep the words the same. And again, attributes here we're talking about are organized into entities and objects. Same thing there. That's where the intricacy comes in. Attributes are these characteristics. Entities are the things whose information is managed. And it's pretty easy to get examples. I already gave you one earlier. I've just named 3 different ones as you go through. They are organized into models, and that creates the dependencies that are there. And again, we've talked about that. And you can look for models all over the place because your existing system is full of them around that. Models then are organized into architectures, which speaks to purposefulness. And when building new systems, architectures, plan development, data managers don't know what the existing architectures are, and therefore they can't make use of them. It's very difficult to come up with examples here because of the insane complexity of these things. So look at it not as a puzzle that you'll eventually complete, but as a perspective that you're going to take and dive in when appropriate, and keep all of that information up here at the high level so that you can make different concerns. Organizations have maintained their enterprise data model in PowerPoint for decades in some instances, and done so successfully. It's not necessarily the prescriptive way to do it, but it is interesting to know that it can happen in that way. So let's take a look at a model real quick, defining these pieces and relating to models to architectures. First of all, the question I would ask you, were we in person, is what does the number 42 mean? And you'd be going, what? I have no idea, unless you happen to have read Douglas Adams' book, The Meaning of the Universe. There we go. On that, 42 is the meaning of life, and only when I pair those two together do I come up with a data. Data is a combination of a fact. 42 is the meaning of life, is the meaning, and fact is 42. Again, this is nonsense so far, but so is a lot of this. The question is not to learn about data, but to learn about useful data. We have to understand the value proposition, very important early on, or we will get mired in details that are not valuable. It's not to say the details are not valuable at all, but some details are not valuable. All right, to get to information, then we combine it with a request. Then we go one step further up, and we have to say, you can't have data without information, but you can't have information without data. Very nice articulation of that. One more level to get to success, however, and that's how is data actually used? Because everybody will always say, give me all the data so that I can go do what I need to. Only after they've had a chance to look at it for a while will you be able to discern between their information and their intelligence, wisdom, or knowledge, also used simultaneously. Notice here that this entire thing now comprises an architecture, even though I've built it out of a model. And you now have a new way of explaining the difference between information and management using architecture and modeling terms. Data architecture requires interoperability. If we're going to have self-correction and generation capabilities, it's absolutely critical. It needs governance, which means we can now point to a piece of that data model, that architecture down here in the bottom right-hand corner, and say that piece needs that aspect of control or governance on it. It's a prerequisite to having any meaningful data exchanges. Somebody's going to send you data. If it's not the right stuff, you're going to throw it right back at them and say, give me different stuff. It lowers the cost of organization-wide storage and extra organization sharing. Again, different organizations I've worked with have asked me to stop when I found too many instances of them purchasing their own data back from the market. Doesn't seem like a worthy expenditure of funds, does it? The data architecture permits rapid evolution. It allows for role-based security implementation. Now, you don't need it to have that, but if you have both, they work well together. It decreases the cost of maintaining your inventory, especially considering that 80% of your data is redundant, obsolete, or trivial. Your data architecture captures the meaning of data. It's a living document. It's constantly evolving to come up. It is mostly abstract and imperfect at first and gets better over time. Don't set yourself an agenda so that you're trying to get to a certain place for a reason. Make sure that what you're doing is value constrained. It's a great entry point, though, for almost all types of engagements in there. And the validated components can be used to populate a business glossary around that. It is the majority of the collection of metadata in most organizations as they do this. And we talk about it again, models face downward, looking at detail. Architecture is a higher level of abstraction. Meeting in the middle is the data here, and that's what we're trying to do, is transfer from an entire building down to a detail on the building around that. The analogy is very good. Structures are organized, remember I said motivation, to support a strategy. Well, first of all, again, consider the opposite of question. If they weren't explicitly designed together, what's the likelihood they will? If we don't know their structure, we can't do anything. So let's take two examples: achieving effectiveness and efficiency goals. If I want to go goals effective and efficient, I might do an organization that has, in a restaurant context, only the bottom type of plates here. The top type of plate looks like it's specific to a dish. So if I want to go with goals, I will create this type of an efficiency goal of efficiency. I will create this type of architecture in there. The same thing can be done with data. We need to understand that there's a relationship between engineering and architecture in the process. Architecture is used to create systems that are very complex and can't be treated by engineering analysis alone. And engineering creates the detail that is needed to get down to that level. Just two quick examples of each of those so you get a picture of it. The first one here is the idea that you cannot architect after you have implemented. The reason you can't change a database after you've already fielded the product is exactly the same reason you can't start these things from the top down. They must be built from the bottom up. By the way, shout out to BMW for their wonderful commercial articulating exactly that particular process. Similarly, I want you to imagine me as the architect of the pyramid, talking to the Pharaoh. Oh boy, now I'm in trouble. And the Pharaoh saying to me, by the way, Peter, you were supposed to put a swimming pool at the bottom of the pyramid here. And I'm sorry, Pharaoh, there's no way. The architecture of the pyramid is that it's a large pile of rocks, and those pile of rocks are sitting on top of a shifting sand. There is no structural integrity that will permit me to put a swimming pool below the pyramid, particularly after it is built. Maybe if we talked at the beginning of the project instead of at the end of it. Again, architectural conversation here as opposed to an engineering conversation, detail oriented. One of my favorite objects in the world, I know that sounds weird, but that's just the way I am. Let me tell you about it because it is one of my favorite objects in the world. It's taller than I am. It has a clutch. It was built in 1942 and it's cemented to the floor. Why would somebody cement something that looks like a mixer to the floor? Well, one other fact, it's still in regular use today. Why is that important? Well, first of all, what was the problem we were trying to solve? We put 4,000 brave warfighters onto the USS Midway and other warships in 1942 and said, go out and fight World War II. By the way, we're losing, so good luck. And at least every morning we will do our damnedest to make sure that you have breakfast, lunch, and dinner, of course, as well. And how do you do that? Well, if you're going to make dinner, lunch, or breakfast for 4,000 people at a time, technically it's 4,400 on that ship, having a mixer that is fine, like the one that I'm showing you here, is not a solution. And it certainly wouldn't be in use here in the year 2021. So engineering is as critical all the way around here. I mentioned before I was going to tell you the difference between a definition statement and a purpose statement. And again, the key here is a definition statement says a bed is a piece of furniture. Cool, no problem. Doesn't tell me much about it, but definition. And if I describe this aspect of it here, and say that the bed has these specific characteristics that we looked at before, we're now getting into greater detail. And what we need to do is put a purpose statement on it and say the purpose of the bed here turns out to have a specific definition. And if we get that purpose statement in here as well, we will capture much more of the motivation, much tighter of the requirements around that. Again, remember it works in both forward and backward engineering modes. We'll get to that in just a second. What's the proper relationship then for these two business things about which we are creating, reading, updating, and deleting information? This turns out to be a key question. If your system already exists, this is a fact and you're trying to learn it. If you are doing this for a system not to be existing yet, but to be developed in the future, then you're trying to find out the requirements for this. Both are difficult jobs. Only one is taught. A bed here is clearly related to a room, but that's not very precise. Let's get a little bit more precise on this. Let's say that a bed is now related, many beds can be related to many rooms, and many rooms can be related to many beds. Again, think of this as holding your fingers up with an M sideways. The wrong way sideways is both cases, but that's how you get to the many. It's not hard, folks. And finally, maybe even more precise here, we would turn out and say, oh, that's really too loose. We don't want to have every bed be better still. Many beds can be contained within each room, and each room may contain many beds. All right. Now, that type of precision gives us more information about this. What if the beds can be moved? Becomes an entirely different question, which is why it's very difficult to re-engineer these old, I use the word old because anything that's in production is old by definition, old legacy systems in there. Now, again, these ways of describing the stored facts that are in here that need to turn into this business rule. Many beds can be contained in each room, and each room contain many beds. And maybe to make it easier, let's say beds can never be moved. Make that an explicit assumption in there. That way, if somebody wants to move the bed, they can challenge the assumption, which is great, or other ways around this. There's lots of cardinalities around this, exactly one or many. Don't worry, we're not going to dive into them here, and they are not hard to learn. It's a finite number, 5 in this case. There are competing sets that are out there. Don't pay a lot of attention. Almost all the old ones are fading away. I hate to say it. It's not that they weren't good, but the competition was much more harmful than was the actual collaboration that happened. So just pick one, and the organization, the industry, everybody has picked information engineering as the way forward on this. So using information engineering, let's talk about a relationship. It's a natural association between two business things about which we are creating, reading, updating, and deleting information. Here's a set of labels for these things here. Ordinality means we're going to talk about the mandatory and optional relationships that exist here. A bed exists in one and only one room, and a room consists of 0 or more beds. You can see there's a slight difference in the way they're described here. A bed is occupied by 0 or more patients, and a patient occupies at least 1 or more beds in there. What if a patient doesn't have a bed? Maybe there's a problem there, but at least according to this system, it cannot exist. So the standard definition says something, you sleep in it. Not very helpful in that. In this particular example, which was an example we grabbed from the Veterans Administration, interestingly enough, I used to work on some of those old systems that were there. This was a description of a bed here, but we suddenly discovered that a room could have 0 beds in it. And we said, how could a room have 0 beds? And they said, oh, well, beds can be moved. And we said, oh, great. What room is the hallway? And immediately we got a 0 question that it didn't understand this. So the status went from unvalidated to draft form. And that's an important attribute to keep about your metadata, validated versus draft forms of these things. So again, we've talked a lot about architecture here. Let's go quickly now to understanding how they're used together. First one is what's taught in school. That occurs on exactly 20% of IT expenditures. So I have to ask why we're doing this, but let's nevertheless see what is taught. We're taught that there are a series of requirements, and then sequentially you design and then you build the asset. Each one of these activities is visited once too. By the way, it's practiced with most students when they leave school, and it's a real problem to get them to do it iteratively, which is what we'd like them to do. Again, they create a conceptual product at this level, they create a logical product at the how stage, and they create a physical product at the as-built stage. This is what we call forward engineering. And in the case of the data world, they're building new databases in that particular process. This translates into the system development lifecycle as it is generally taught, where requirements are followed by design, followed by implementation. And of course, there are good, valid, agile implementations of this as well. I just don't have time to cover them all. But yes, they do a great job in that area. So what's really happening out there in the world is we're spending 4/5 of our IT dollars on the process of understanding and improving our existing systems as opposed to building new ones. And that's a very different challenge. And it's a challenge that's particularly well articulated by a fellow here named Fred Brooks, again, who most students are unfortunately not exposed to. But he's the one that came up with the concept of the mythical man month, the idea that adding more people to a late IT project makes that project later. He also then came up with a wonderful observation about data, which is that data representation is the essence of programming. He says, show me your flowchart and conceal your tables. The data, I will continue to be mystified. Show me your tables and I won't need your flowchart because the answer will be obvious. And he's correct. Reverse engineering, though, very, very rarely taught, is the idea of going back and understanding what already exists to leverage it in support of enhancement efforts. And my friend Elliot Tchaikovsky, thank you, Elliot, put this one together. The idea is we go from the physical back to the logical and perhaps up to the conceptual as well. If it's mentioned in school, it's wonderful. Students, certainly in a 15-week course that consists of project management, analysis, and design, is a very, very difficult task to figure out how all this works together. So the best we can hope for is that it's been mentioned to them around that. What this means is that it's very difficult to get them to work together, to use it to the full extent. And the idea here is that we've got to come in most cases, especially if we are changing the requirements, you will go the yellow route on this. First, understand the existing systems, reverse engineer it to understand its strengths and its weaknesses. After all, if you do not at least understand the existing system's strengths and weaknesses, how are you going to avoid building the weaknesses into the new system? And how are you going to build the strengths into the new system? And again, we haven't even talked about motivational in this. So very important, the definition of reengineering is to first understand and then use that knowledge in building a better set of next generation systems on this. Most cases, you're not going to revisit the requirements. You'll go straight to a redesign over here. And only when you have used the information from the existing system into the new design of your system should you implement it in a re-engineering context. In most cases, data modeling works in somewhat of a following fashion. If you're building from nothing, you're identifying the entities, maybe just classes of things that the business is going to create, read, update, or delete about. You're going to identify a key for each of those individual pieces. You're going to draw a rough map of the relationships that's there, and that's going to be okay. And then you've got to stop, walk away, come back, and then at a later stage, add some attributes and see if your original piece makes sense. Sometimes you'll need to reorganize it, sometimes you will not, but that iteration always helps. It's very easy to identify the point of diminishing returns. Usually it's after the third iteration that you will end up with something that is closer to what goes on and can be much more productive for you as well as your colleagues on this. The iteration might eventually include reorienting the data set. Remember, you can do that as long as the data isn't built. If you're specifying a new data set, you're likely specifying a brand new system all the way around it. You may uncover new relationships in the process of doing that. Your data architecture and modeling evolution should be somewhat like the following in doing this. The activity of grabbing evidence and analyzing it will diminish over the series of modeling cycles that you're going to do. Each modeling cycle should be focused on a specific goal contributing to the overall success of the problem. That analysis portion will increase along the way. Project coordination activities decline along the way, unless you're in some sort of weird political situation. But if mostly after they figure out you aren't going to hurt their existing system, they're okay with that. And our amount of target system analysis should increase over time, as should our efficiency in the process. And our change from modeling draft items to modeling validated items should occur going through that process as well. So our overall process will evolve as we're doing this. Let's talk about a couple quick takeaways on this. The first one, again, is remembering how these two relate. The attributes are organized intricately into a range of things that are grouped together as entities. These entities start to introduce dependencies, among other things, into the models that become challenging for us around that. And I showed that particularly with the definition of the information in there. The models are then organized into architectures. I did the data model of this little piece over here for the purpose, of course, of illustrating, in this case, what you're doing. But in general, our problem is that architectures are really, really challenging, really problematic, and very hard to show on a single PowerPoint slide. So hopefully, out of the last hour of your valuable time, you have gotten the idea that data architecture and data models are looking at two sides of the same coin. They are made more useful by doing more of each other. And that thing, the reason is they're working on exactly the same product, a group of metadata that also should comprise your metadata repository, your business governance, your glossary, et cetera, et cetera. The power of this is derived from the interdependence of the two. And the data models are a primary means to achieve shared understanding of data challenge specifics. In other words, not we want to learn everything about all the data out there, but what about the data is challenging us at the moment, and how can we best use data modeling to fix that? Hence, the purpose of this data model is to solve a problem of one form or another. There are pages that help people understand. They are the pages that understand, that give the understanding of this. And once you create those pages, just hang on to them, give them to a librarian of some sort, keep them in some form or another, and that will help you to start what you're doing in terms of architecture if you haven't started on it. Likely somebody in your organization is already doing this to a bit. The data architecture is then the sum of the data models. Your coverage is rarely complete for the entire organizations. Similarly, data models are combinations of documentation, currency, ways that we verify integration, mandated use before we do any data systems collection. But what is taught is mainly forward engineering with the goal of building something new. What is needed in our world today is understanding of what is out there so that we can learn more about what's going on. We're getting close to the top of the hour here, and I want to thank you guys for taking time to spend time with us today and learning about a strange topic like data architecture and data modeling. But we now get to the part of the show it's most fun for all of us, diving in with see if you can stump the chump. David, hey, we're ready for you on this one. Got a couple of upcoming events around all of this, and Shannon, I will turn it back over to you unless you want me to talk for 30 seconds more, which is where I get paid by the minute, right? Actually, I'm going to tell a story on Shannon. I just wanted to make sure she was listening at this point, which she always does. So when I was learning to drive, everybody, I was a student driver. I don't know if they still do that, but I had a guy who looked like he slept by my side as I was going through things. And, basically, I guess I knew what I was doing. But one day as we were starting to cross the intersection, he just didn't even wake up, but reached his foot out and pushed the second the second brake pedal that was on his side of the car and stopped me from running out in front of a line of traffic and getting us both killed. And Shannon did the same thing this afternoon by getting us that the video wasn't working well. So I hope that Steve Jobs article was interesting enough for you to go through a little bit, but we look forward to your questions. There you go. Now I ran over by 15 seconds.
I love it. Well, thank you, everybody. And if you have questions for Peter, feel free to submit them in the Q&A section of the screen. You can find the Q&A icon on the bottom middle of your screen to open that section. And we have the fun little option set up for the Q&A. If you see a question typed out that you were going to ask and you want to ask, you can click that little thumbs up instead of typing it out again yourself. So you can just upvote there the questions. And to answer the most commonly asked questions, just a reminder, I will be sending a follow-up email to all registrants by end of day Thursday with links to the slides and the recordings. So everybody will have access to both of those. So diving in here, Peter, lots of great questions coming in. How do you create a data model architecture when the critical apps are software as a service?
What a great question. Now, take this important information back with you. It turns out that the data architecture is the only thing that can tell you how these separate off-the-shelf apps or your ERP or whatever it is that you have are actually connected. It literally is the connected tissue. You can start off by doing what's called a data flow diagram at a high level for the organization between the various applications. What general sets of data go into, what happens to them internally, and then what goes out of these data sets. And that will help with everybody to understand a large picture of what this looks like. That data flow diagram becomes a component of your data architecture, and keeping that so that it's accessible so that other people don't have to do the same thing. It happens so often in so many organizations. They repeat the work in one form or another. In order to come up with this, and it's just unnecessary, but it also requires a good librarian. Luckily, most organizations have somebody that functions informally as a librarian. If you don't, look around and see if you can find some way of sharing your stuff. The open source community has done a wonderful job of doing some of this, but it may not be helpful with that back of the envelope calculation that somebody literally handed me at Deutsche Bank back in the 1990s, saying, somebody says, you like metadata, so here you go, here's some metadata for you. And we in fact put it out there as Ron's napkin, and people got it and looked it up more than 5 years after the initial fact. That was way too much information, I'm sure, that you were asking for, but I was loaded for bear on that one in case you weren't ready.
I love it. So I guess one of the struggles is to keep logical data models up to date and in sync with what's implemented. Oftentimes logical data models are built to satisfy project requirements. And once project is over, we leave it aside and no one touches it until a new project comes to replace the technology.
My favorite example of working with a group of data professionals in my 30-year career, as I mentioned, is the U.S. Marine Corps. At the time we were working with them, they knew exactly what they knew and exactly what they didn't know about their major mission critical system that we were working on collaboratively. They could tell me within a series of months how up to date their metadata was in this area. That's excellent in terms of being able to do this. And they also knew what they needed to do so that when they found extra money in their budget, they would go back in and bring the documentation up to date. Most organizations are not as mission driven and do not recognize their systems as being as mission critical as the US Marine Corps recognized this mission that this system that we're talking about as mission critical in that sense. So consequently, there's less of the motivation around. Nevertheless, if you're able to take that documentation that has been created at the end of the project, as you said, and somehow make sure that it's accessible to future people going forward, and the technologies are getting marvelous about being able to do this without needing to invest seven figures in it. In most cases, we build organizations their first repository, glossary, whatever it is we're working towards in a series of weeks, and it starts to get positive return on investment almost immediately. It can be done. It's a little bit beyond the scope of this webinar to do, but I hope that gives you information that you were looking for.
Perfect. And certainly you can add any additional inquiries in the Q&A if you like to that question. So Peter, most of my career, my title has been data architect, and my tasks have included most of what's involved in the DAMA definitions of data architect and data modeling and design. So do you feel that the discussions around this topic are more theoretical than they are practical? Do you find the lines that these roles are kind of quote unquote fuzzy, and that they are in my experience? I'm a data architect that produces maps, data models, roadmaps, designs, SQL scripts, SSIS packages, the list goes on.
I think maybe instead of focusing on what you produce, if you focus on what you produces, you will have an easier time in getting people to recognize what your role is. But you're right, as far as a topic and a class of jobs, it is difficult. Even among the CDO community, the top data job, the enterprise data executives, that knowledge, the way in which they approach it is widely varied. But let's concentrate on your question. Interestingly, there are only two categories tracked by the US Department of Labor. And we've been trying to work with them over the years and haven't managed to connect with the right people to ask that they include the number of things they track. Because right now, the only two job categories in data that the US Department of Labor tracks are data modeler and data architect. So literally, as far as they're concerned, everybody in data falls into one of those two categories. Now, the fact that you have confidence in yourself as a data architect says more to speaking that you understand your strengths in there. And I'm going to guess your strengths are generally around problem solving, because most architects are focused on that kind of a process. If you've got something that's going on, they want to know what they can use architecturally to solve that. And I'm going to put this in context of the lecture here, just so that everybody can hopefully follow along with this and sort of realize the role that architects play. And that gets to this particular slide where we talked about the models being developed for a specific purpose. And the idea is, if the model exists, we can go access it from the library, and that'll save us the time of trying to derive it ourselves. Nevertheless, with proper technology, we can derive a logical third normal form from any data collection that has relative amounts of tabularity to it. Non-tabular data is much more difficult to deal with, but nevertheless, we can still find structures across there. We can't guarantee the third normal form. The architect comes in and says, in order to solve this problem, you need this architectural component. And to design that component, I'm going to specify a data model. Or the architect may come into it and say, I'm not building you anything new, but I'm going to find out why your problem exists by examining this portion of the data model. And I'm going to take that detailed examination and place it back into the library so it can be reused in the future, because that is related to specifically a one-to-one correspondence. It's a physical as-is model to the existing information system, and it does represent the existing requirements. Remember, we said we're going to put a feedback loop on it. And certainly, this process keeps occurring over time. So the lack of documentation doesn't hurt you the first time that you have to look at it, but the fifth time that you've had to look it up and do this. And as an architect, what I would also urge you to consider is to start to tally around the kinds of business value that you saved. I had one person that actually tallied it up in eggs that were spared. And I know that may not seem much, but for some organizations, egg sparing is a very important activity and a very profitable activity that served him well to, in this case, use that as a measure of what he was trying to do. So it's tough as an architect to say, I'm going to do something, but if you can cast it generally as the idea that as an architect, somebody's coming to me with problems that either have been designed or haven't been designed, and that they need to be understood so I can then design a solution through that reverse engineering and re-engineering method that we talked about at the very end there. There's a very good possibility that you will be perceived in a different light as somebody who comes to the meetings and talks to us about data, but I don't really get it to. I want to make sure that individual is at this next meeting, because that's the kind of thinking that I like to have on that. I'll leave that particular discussion with just a Dilbert, if you can imagine this. It's the pointy-haired boss who then says to Alice, Alice, I've noticed a disturbing pattern in your productivity. The thing that's correct that you think of as an analyst is always the last thing that you think of. Is there any way you can improve upon that? I'll just leave it at that, Shannon.
Perfect. So Peter, in relationship to master data management, do all attributes of a thing get mastered or only some? And if some, how do you determine?
It's a really good process and a really good exercise to actually make groups practice through. They don't have to be exhaustive about it. But what you're trying to determine there is a concept that has been labeled the essential information in the model. If you do not have the essential information, it is not in the model. If the model does not have the essential information captured, it is not a complete and not a useful model in that context. So the key for doing a data modeler is to be and understand the essentialness of the model. I use an example of my laser pointer back in the days when we used to meet in person, and I could see you guys face to face and it was safe. I would describe my laser model and say, if you're making a laser model, excuse me, if you're making a data model of Peter's laser pointer, I don't know why I get those words mixed up. If you're making a data model of Peter's laser pointer, is that different from the data model of a laser pointer in general? And the example that I would describe is, what are the essential qualities of a laser pointer? Most people would say it points with a laser. Okay, great, no problem. The laser model then points to the laser, points with the laser. If Peter, though, if you watch Peter present, Peter uses a fancy laser presenter. What it does, it not only points laser at the screen, but it also advances the slides forward, so you can dance and sing and look at all the things that are fun in order to do this. The Peter's laser model, excuse me, laser pointer also is green. Used to be in the old days when I was the only person with the green, you would get labeled the guy with the green laser pointer because they couldn't remember your name, but boy, did they remember that laser pointer on that. For a data model, having a red laser is an essential characteristic, an essential component of being a laser model, is probably a decision that you would make as a data modeler. But if you're describing Peter's data, Peter's laser pointer, you're probably going to get from the discussion with me that for me, the fact that both it's green and that it advances and goes back on my slides, it also zooms and does other cool swoopy things around all that. That's an essential characteristic for me because I'm what you might call a serial presenter, where I will show up for anybody for any time and talk about data. I'm one of those insane people, but I do go away when I'm asked. So please don't be hesitant about inviting me to come speak with you. Anyway, back to you, Shannon. I hope that was a good coherent answer on that, because I think I got it.
Nailed it.
You'll tell me if I get incoherent, won't you, Shannon?
I will. Indeed, always. So many great questions coming in here. I love it. What is the starting point of designing a data architecture that is aligned with the business strategy and goes in harmony with the rest of the enterprise architecture, business and security, et cetera?
What a great question. So the key for starting out in your data architecture from that perspective is to look at it from a value proposition. First of all, is there a problem right now that you can be portion of the solution? Now, important thing to recognize about problems in organizations, they are all data problems. There isn't a problem out there that doesn't have data in it as a component somewhere. It may not be yours to play a useful role in, but if you don't go look for it, and more importantly, teach the knowledge workers in your organization to also go and look for it, you will never find these problems. Data manifests itself through a series of IT system and process problems, challenges to the organization. But I guarantee you that all organizational challenges have a data component of them. Go and look for it and see what you can do to find that and solve that problem. And then, by the way, show that perhaps it may have taken you a couple of weeks' time to solve that problem, but that at the cost of the overall problem in the organization. Remember, our 20 to 40% of IT costs are spent doing this in a manner that is completely unproductive for most organizations. It's just flushing money down the toilet, and yet they won't recognize that these are the challenges. Sorry, I went off on a high horse there, Shannon.
Yeah, I love it. My Q&A keeps disappearing. There it is. Okay. I know. What is your response to data modeling is dead, long live schema design?
So first of all, it's a wonderful thought from a development perspective. If you can generate the schemas, case tools did that years ago, and we've always supported the idea that if you can have a machine do it and train people to understand that their role is not to correct what the machine did, but to correct the way the machine does the specifications, it works very well. It's a hard thing for people to learn and understand, but more importantly, remember, 80% of IT expenditures are on as is existing stuff that you are fixing or improving. That requires us to understand the as is requirements. If they are not documented, you need to use data modeling and architecture to go recover that knowledge and get there. It's not anything you have to buy equipment or expense for, but most of the case tools these days can hook up to large databases and reverse engineer them in a matter of seconds, particularly if the database is a common database. That can be a simple problem, but yield tons and tons of value in the process. We don't tend to make people aware that that is an option. And I should have probably had a slide on it in the seminar, so thank you for bringing it to attention. We'll take a note and add one in for next year. That great question, thank you.
Indeed. So how is data architecture dealing with the physical location of data, for example, regarding, EU GDPR?
Critical to make sure that you have either a partner that is handling that risk or that you understand the way in which you are approaching the handling of that risk. Again, from an organizational perspective, they're going to go after the money, no question about it. Virginia just passed a data privacy law that you must now pay attention to, except for the fact that we apparently gave the only person in the state who can actually sue a company for violating a Virginian's data safety is the Lieutenant Attorney General. There we go, the highest law enforcement. So it's going to be a pretty big crime to rise up to that level. But our questionings are really, what is it that we're trying to solve with respect to this? How can we use the process of architecting and engineering our data to really try to make sure that we solve a problem precisely? So many of the times I will get students and business people go, well, I think it's this. It's like, it's not good enough to know that you think it is. You have to know precisely what happens here, or you will waste time and money. And if you're only wasting your own, that's great. Usually it's a lot more of the organizational components that end up in there. And we didn't talk much about how to do the valuation, but again, we talked earlier about finding that value component. Basically, if you just start counting, that's a really good way to look at valuations. I found a query once that ran 14 billion times a day. How's that for a find? If that query could have made just a fraction of a second more efficient, it would have added up, and very, very rapidly. You'd be amazed at how much this stuff works. The question was around the idea of, where does data architecture show in terms of where the data is? With that as a problem of a risk problem, it's important to understand that if they're trusting you to solve it, you have to make sure they understand that they appreciate your approach. One of the challenges that happened with Nike in the process of the sneaker blowing on the basketball court last year sometime was that they discovered not all the data was under their control and that they could learn where it was. They learned a lot about data governance under fire in a hurry. And it was not a lesson that you necessarily want to have under fire or in a hurry. It's something that as architects, you should be explaining this and talking not necessarily about just the physical location, but tying it back again to purpose. The reason we're putting it in the cloud, for example, should meet at least one of my 3 theoretical constructs around data in the cloud. Data in the cloud should be, by definition, more high quality. Higher quality data should exist in the cloud. If you don't believe that, try to do it the other way around. The data in the cloud is of lower quality. Not good. So you can use this point of inflection of transferring from the physical on-prem type thing moving into the cloud as an opportunity to produce data of known quality, as opposed to most of the data that you have out there right now, which is of unknown quality. Again, same 1 in 10 metrics apply to that process. Also, the data that's in the cloud should be more shareable by definition. That's an architectural feature that you can engineer into the data models that you are producing. The shared data models that you are producing in the clouds should be more shareable. That's an objective characteristic. And as a result of 1 and 2, the data in the cloud should be of actually significantly less volume than the data that's on-prem, because you should be only moving roughly 1/4 of it, although in my experience it's closer to half the data, but even that still does represent a substantive savings, both in terms of scope of what you're attempting to manage, as well as in terms of what you are forcing other people to navigate over the system. I've seen organizations get down to as close as 1/3 of their original data sets, and that does represent substantive process around that. But it's still a challenge apparently to get to the last 20%, but still reducing your data volume by 2/3 is a achievement that would be useful all the way around. Certainly much more data information than you asked for about physical locations of where these things are. But the map is something that you can use to help educate everybody to what's happening in there. Partition the map, show the difference between data over here is one way, data over here. Use it as an opportunity to brand your data as an architect and say the data that exists in the company X cloud. And therefore it can't go into the cloud unless it's of known quality. And therefore we have better, high quality, more accessible data here in the cloud. And on the outside of the cloud, data is less. And people will eventually stop saying, why are we getting our data from the left side of the diagram, which is the higher quality, more accessible, less in volume to learn data than is the data that is spread throughout our legacy systems all the way around. A really wonderful teachable moment, again, just to finish this off, was our own university hospital system here at Virginia Commonwealth University. The chief information officer at the time eventually had trouble because they were bringing in a package very similar to the question that was asked before. And the management said, well, we're buying a package. We don't need data architecture anymore, right? The software will take care of all of it. And so the first thing that Barbara Baldwin did by pulling this thing together was create a model in PowerPoint, very much like this. Not this one, in fact, give me a minute, I could pull it up. I won't bore everybody with that. But it showed clearly what was going to be part of the new system implementation, what was not, which was a lot, and said that, yes, you are simplifying my challenge somewhat, but it's not going away just because you bought some software. I still have a data architecture that needs to be maintained for the purposes of, oh, by the way, for mission for data architecture, how about keeping people alive? Yeah. We used to do that with VAXs, if you can imagine that in the old days. VAX didn't stand for vaccine in those days. It stood for a type of computer, the VAX computer. That's all it was, just called a VAX. Boy, how the world has changed. Anyway, I went on and on there about data models, but location can be used to link to data quality, to data motivation, to data capabilities, all sorts of things there. And all you're doing is typing the data and saying we're providing some known qualities around it, that this other data we don't know about, and where most people are going to prefer to get their information from the known quality rather than the unknown quality. Did I babble enough on that one, Shannon?
It's good. And I love all these data modeling questions.
Maybe we should just do a session on data modeling questions, stump the chump or something.
No, I love it. It's I've had a little theory we need to do more on data modeling, so it's good. Yeah, so speaking of, how does graph databases, or how do graph databases affect data modeling?
Well, beyond the scope of the problem, in terms of understanding architecture versus modeling, in that you're probably not going to build them in the same context. Typically, it's going to be easier to build the graph and then derive the metadata from the information that you have there. I'm not aware of any specialized tools, but I haven't done as much in that area as others have. So maybe there's somebody in our community that knows of specific automated support for those on there. I think probably closer to visualization tools may be the way to go in that area, but that's just a guess. Anybody else want to weigh in there? Drop it in the chat for us.
And are conceptual and logical data models enough for an agile environment? No time for physical?
Unfortunately, that's one of those it depends answer. The general approach is that doing all three is not typically done anytime. Typically, it's two of the three that are done, and then perhaps a generation step or something in there. Although different forms of it have come together over the years, and it's been interesting to observe that. And for those of you that aren't, what we're talking about here, let me see if I can get to the. Well, that's all right. We'll leave that off for anyway. It's tough to get the ideas across with the type of problem that you're doing unless you start to transcend these levels. And I think that's what the questioner is getting at. There are different types of models that are useful for different points in time. Typically, the business user are going to have the more abstract piece, the one that's going to be probably more expressive in business terms and less expressive in technical terms, which is the other end of the spectrum, the physical as is data model that you would then go down deeper into in terms of technical details.
And Peter, I like the, oh, this is a comment from, I like the expression data archaeology. It's kind of what we do.
It is, and it's a wonderful thing. I realized this in the 90s when I just had a very strange career, as you guys know, but I was working for the US Department of Defense. And at one point we invented the technique data reverse engineering with a couple of colleagues. And then they ordered me to write a book on it. And I was just flummoxed and said, could you really write a book in that sense? And can you really order somebody to do that? And they correctly said, you want to ask that question twice? And I said, oh, I understand. Thank you. I'll get right on it. Yeah, strange way to start off on these processes, but it's just not known how these things are supposed to be used, under what circumstances they're useful. And it's important to know that it's a tool of many types of tools that you have as an analyst. I didn't actually have the Abby Covert example in here, and that's worth looking up as a book, especially if you're a Kindle subscriber. It's very easy to acquire on Kindle in there. It has all the pictures in it. It's a great way to explain this to people. And part of this is sometimes I'm explaining it to business people to make sure I understand the requirements correctly. That's going to be more conceptual and logical conversation. But on the other hand, if I'm examining the existing system and trying to figure out what the heck was going on so that I can correct a defect, particularly under circumstances where like the pipeline's locked up or something, could be a problem, right? And it does happen on a regular basis. Then I'm going to be more at the logical, physical level around that and trying to come and understand the existing system in terms of what's there. It's a tough problem. It's not understood well. It's not hard to do. Sometimes it's as easy, literally, as hooking your case tool up to it and pushing a button, and it comes back to you in a flash. It's a wonderful exercise we run the students through on a regular basis, just so they have an appreciation for it. Anyway, I'm babbling too long, and we're not going to get to your questions, so I'll shut up.
No, it's good. I love it. So there was the question that came in initially, Peter, on the data architect role. So use case, client needs a data warehouse, architect roles, data warehouse architect, highest level for the overall design, data architect, overall design for the data aspects of the warehouse, mostly logical, some physical, data modeler, produce conceptual, logical, and physical data models to be initiated in the database, technical architect, infrastructure to design, application architect, BI stuff. None of this seems to be at the enterprise level, and the data, it's so fuzzy in how to, again, clarify all of these roles.
And what I contrast it with is, unfortunately, we're just going to have to live with a little bit more imprecision than perhaps some of us would like at the moment. Many of you know that I'm married to a professional in the accounting profession, and she points out that she has a practice that they're not forced, but encouraged to go by. 80% of the organizations do. It's called Generally Accepted Accounting Practices, GAAP. And the accounting profession evolved GAAP after 8,000 years. And probably that's an unfair number. Really, double entry accounting system was invented in the same century as the Gutenberg Bible. So, maybe it's hundreds of years rather than thousands of years, but it nevertheless took a while to evolve over time. What are the best practices? Our profession, the data modeling groups of the world, really dates back, in this case, to the British Secret Service in World War II. And they realized that they had persons of German descent living in the United Kingdom, that they were at war with their home country. Uh, and instead of deciding to throw them into intern camps, they just put a computer card together on each of them. And then they went, oh my, how are we going to manage 14 million cards? So yes, the roots of our profession go back to the British Secret Service. It's a fascinating little story about that. But it also means that we've only had a century or so to develop. In fact, we look at the godmother of our profession as being Augusta Ada King, and she is the idea of starting all of this. She conceptualized programming, and then the idea came up with also the process and data model along the lines around that. Again, it's a new profession, so it's not going to be clear at first to do. Best to do it is to stick with a couple things that are clear and work with them. You mentioned many different types of architectural roles. It's much more important that your organization learn the difference between a data architect and a modeler at this point. One is going to be one type of thinking and approach to the problem. The other is a different type of an approach. Both are generally needed for most problems. One final piece on this before we run out of time, and that is the idea that what I didn't hear in your solution, and it's certainly not a picking of a fault, but something that we do need to recognize as architects, is that most of our solutions have been done and documented before. There are 3 wonderful collections of data architecture documents. I'll put a list together for you that we'll include with the slides at the end here. But David Marco, Lynn Silverstone, David Hay, myself, a couple of others have put together some wonderful books that have common data models. When you start to do this, it's very unlikely that you will be unable to Google and find something relevant about whatever system that you're looking at. Shannon, I think we're out of time, although you know me, you can wind me up and I'll keep talking forever.
And we are out of time. It's perfect timing. So thank you, Peter, as always, for this great presentation and Q&A. And thanks to all of our attendees for being so engaged in everything we do. We just love it. Again, just a reminder, I will send a follow-up email to everybody, to all registrants, by end of day Thursday, with links to the slides and links to the recording. Thanks, everybody. And thank you again, Peter. I hope everybody has a great day and stay safe out there. Thanks
See you
all.
in June. Thanks.